So guys, last meeting, we started how to figure out the first stage of your concrete beam. If you have a beam and this beam has dimensions B, H, and I can figure out the value of M crack. If you have a moment, this moment will create tension in one side. Keep this scenario in your mind all the time, how your reinforced concrete beam behave. So if you have a moment on the beam, we have tension in one side, we have compression on the other side, we have neutral axis in between. Since concrete at the bottom under tension, if this tension is still smaller than or equal a value is called FR, concrete is still good. And this FR, which is modular ratio, equals 7.5 square root F prime C, according to ACI. So at the time this concrete just before cracking or just before the tension is almost equal FR, at this moment, the applied moment can be called M crack and it can be figured out using this expression. If you remember, FR time I gross divided by YB. The value of FR is given according to ACI like this. I gross equal moment of inertia. If your cross section is rectangle, it will be BH cubed divided 12. If it's a rectangle cross section. If it's something else, no, we have different technique to figure out the I gross, and this technique you learned it in engineering mechanics. I will remind you with it. YB is the distance between the neutral axis or the centroid and the bottom of your cross section. This is YP. And we did one example last meeting. And we figured out the value of M crack. If you have steel reinforcement and you are looking for M crack, please ignore it. Everybody in this room should be aware why we ignored steel reinforcement. Because the tension at the bottom of the cross section, concrete still good. Concrete can support this tension. So we don't need steel reinforcement. This is the main reason why we can ignore it. In this example, we are given a cross section looks like T section, not rectangle. And we would like to figure out the value of M crack. What is the value of cracking moment? Okay. Your M crack equal FR time I gross divided by YB. The value of FR is very easy. 7.5 square root F prime C. I think F prime C is given, compressive strength of concrete. And we have a long story behind this number. So equal 7.5 square root 3000 PSI. I can figure out the value of MFR, easy number. 7.5 times square root of 3000. I got a number here, 410.8 PSI. Unfortunately, to figure out the value of I gross and YB, we must figure out where is the centroid of this cross section. if your cross section is rectangle, your centroid at the mid height. So I can say this is YB, this is my neutral axis or x-axis. I can figure out the value of I gross equal PH cubed divided 12. Easy, easy case. And this YB equal H divided 2, where H is the total height. This is easy. But if your cross section is rectangle, I'm sorry, T section, where is the centroid? I cannot figure this out until I can do some calculations. Just a reminder for something you learned during engineering mechanics. I will divide this cross section to two parts. The first part, part number 1, and the second part, part number 2. The centroid for the first part is here. The centroid of the second part is here. And I'm going to assume a reference at the bottom of the cross section. If you would like, your Y bar, which is the height of the centroid, equal area of the first part. Do you remember what are the dimensions? 65. Excuse me. 65. 27. Yes. So the area of the first part will be 300. Fine. What is the vertical distance between the centroid of this part and your reference? The vertical distance will be 29.5. Guys, this is area, this is Y distance. The area equals 60 times 5. The Y distance is the distance between the centroid of this part and your reference at the bottom. This is Y number 1, and this is area number 1. Plus, what is the area of the second part? Second part, this distance is given, I think, equal 12. So the area of the second part will be 12 times 27 equal 324. What is the vertical distance between centroid of this part and your reference? This is area number 2, and this is Y number 2. I think it will be half 27, 13.5. Divided by the total area, 300 plus 324. So you can find what is the value of Y prime. Y prime equals summation of all area times Y divided by summation area. So since this cross section has two parts, so area 1 times Y1 plus area 2 times Y2 divided by area 1 plus area 2. Does that make sense? So the Y distance will be 300 times 29.5 plus 324 times 13.5 divided by 300 plus 324. I got 21.2. So at distance from this reference, which is at the bottom, at distance 21.2, I can locate my neutral axis. Or I can locate my centroid. So your centroid at distance 21.2, I can put here the x-axis, and here is y-axis, and here is my centroid. Does that make sense? That makes sense. If your cross-section is not a rectangle, and your centroid is unknown at the mid-height, if you have something else, unfortunately, we need to locate this centroid. It's a very easy step. You learn this in engineering mechanics. I will assume a reference at the bottom. I will divide my cross section to different parts, 1, 2, 3, 4, whatever. And I will multiply. The numerator will be area time y. Area time y. What do you mean by area? Okay, area is length by width. What is the y? Y is the vertical distance between the centroid of this part and your reference at the bottom, divided by the total area for all of them. I can figure out the height of the centroid. Keep in your mind, if you have a rectangle with B and H, and your centroid or your x-axis passing through the centroid of this rectangle, your I equal B H cube divide 12. That's it. But if you have a rectangle with B and H, and your x-axis is here, that means your x-axis does not passing through or is not passing through the centroid of this rectangle. That means your I will be BH cube divide 12 plus something. Area times distance squared. And the distance is the distance between the centroid of this part and your actual x-axis. And the area is the area of this part. Keep in your mind these two situations. In the example that we covered before, the centroid and your x-axis passing through the centroid of this rectangle. So the value of I gross equal BH cube divide 12. That's it. But right now we have this part with this centroid. Unfortunately, your x-axis is here. That's right. So we have distance in between. For the second part, this one, the centroid is here. Unfortunately, your x-axis is located here. So we have distance in between. So we have to use this expression. That makes sense? So if you would like to figure out I gross, I first located where is the x-axis. How? Using this technique. Okay. Second, if you would like to figure out the I gross, okay. For the first part, this part, it will be 60 times 5 cube divide 12. This is BH cube divide 12. I need to add the area of this part, 300 times the distance square. What is the vertical distance between the centroid of this part and your x-axis? Anybody can tell me what is the y distance here? Any help?
I'm calculating it now.
8. If you are not agree with me, let me know. 8.3 square. The distance between the centroid of this part and the bottom, 29.5. And the distance between the x-axis and the bottom, 21.2. If you subtracted the two numbers, you can get 8.3 square. I need to add plus another part. We have another part here. Can you see it? This part. BH cube divide 12, it will be 12. B times H, which is 27 cube divide 12. Unfortunately, I need to add another part, which is the area. 324 for this part times distance square. What is the vertical distance between the centroid of this part and your x-axis? What is this distance? 21.2 minus 13.5. I got 7.7 square. If you are not agree with this number, let me know. This is how to figure out the value of I gross if you have something else is not rectangle cross section. So 60 times 5 cube divide 12 plus 300 times 8.3 square plus 12 times 27 cube divide 12 plus 324 times 7.7 square. I got 6184.96. 60,184.96 inch to power 4. One more time, just give you a hint. If you have this T section, first step, I need to figure out where is the centroid. I know I can divide this cross section to two parts. Here is the centroid of the first part. Here is the centroid of the second part. But where is the centroid for both of them? I need to assume a reference at the bottom. And y, the height of this centroid, equal area 1 times y1 plus area 2 times y2 divided by all area 1 plus area 2. So y1 is the distance between the centroid here and your reference. This is y1. And this is area 1. This is area 2, and this is y2. Once you set up this equation, will give you a number. This number will tell you where is the height of your centroid. So I can say my x-axis will be here. And here is y-axis. Once you located your centroid and your x-axis, I can figure out the value of I gross for each part. Part number 1 plus part number 2. Keep in your mind, for part number 1, it will be bh cubed divide 12. But I need to add the area of part number 1 time distance 1 square, the distance between the centroid of part number 1 and your x-axis. Second part, bh cubed divide 12 plus area of this part time distance square, the distance between centroid of this part and your x-axis. Then I can figure out the value of I gross. Your value equal 60,184.96. The last quantity I'm looking for is the value of YB. Anybody remember what was the value of YB? The value of YB is the distance between the neutral axis and the bottom of your cross section. Here is the neutral axis. Here is the bottom of your cross section. So this distance YB will equal 21.2. Now I can put my numbers. M critical will equal FR 410.8. I gross 60,184.96 divided by YB 21.2. So I can figure out my number. I will get it, just a second. Your number will be something very big, 1166.22, 5.5. Do you remember what was the units of this value? Pound dot inch, pound inch. I would like to convert your value of moment to kip foot. Anybody remember what should I do?
Divide by 12,000.
Thank you. It will be 97 97.2 kb foot. .2 kb foot. I have another question which is not included in this problem, but it will be included in one of your coming exams. Okay. We have this cross section, and I found the value of M crack equal 97.2 kb foot. And this beam looks like this under the effect of uniform distributed load, W kb per foot. And the span of this beam equal 20 feet. Can you tell me what is the maximum value for W to prevent any crack in the concrete beam? So I started to mix between structure analysis and the concrete design. This value is coming from concrete design. Value of M crack coming from all of these calculations. What is the part of structure analysis? This beam, which had this cross section, is represented by this one. Keep in your mind. If your beam looks like this, if you did cut and look to the cross section, your cross section looks like this. But we are not drawing a 3D, because if you would like to draw your 3D, your beam will be like this. That makes sense? So we represent this 3D with just a line, and this line is drawing like this. Okay? So one more time. If you have beam with 20 feet span and uniform distributed load, anybody in this room remember from structure analysis what was the bending moment diagram? Parabola. Do you remember what was the highest value of this moment? W L square divide 8. If you have more W, if you have more uniform distributed load on this beam, you will have more moment. More W, more moment. More W, more moment. But we are looking for what is the highest value for W before cracking, before the tension exceeds the tensile strength of concrete. So if you put your M as your M crack, I can tell you what is the value of W maximum. Does that make sense? So M crack equal 97.2. Your W is unknown. Your span of this beam equal 20 feet. So 20 square divide 8. The only unknown in this equation is W. I can figure it out. So your W will be 1.9 kb per foot. So the final conclusion, I can put on this beam with this span 20 feet and this cross section of rectangle of T section, I can put uniform distributed here until 1.9 kb per foot, and I don't need any steel reinforcement. No need. Do you know why? Because the applied moment, which is coming from this distributed load, will equal M crack. And the M crack means we have tension, and this tension, the concrete can support it without steel reinforcement. Does that make sense? So keep in your mind we have a good connection between structural analysis and the concrete design. Structural analysis will give you, under the effect of the applied load, can give you the bending moment diagram. And what is the value of this bending moment diagram? Sometimes we can make comparison between this moment and the moment which is coming from concrete design. In this case, I make equal between the bending moment diagram from structural analysis and MCRAC to figure out how much load we can apply without cracking. One of your problem in the coming exam looks like this. Anybody has any question?
No, sir.
Looks good?
Yes, sir.
Okay. Andrew, are you still here?
Yes.
Okay. What we have here? You should, all of you are here. Branding is an adjustment. Yeah, I think all of you. Okay. We are missing one. The basketball player. Okay. By the way, we have a concrete project during this semester. It will be a very big one. And we are preparing the money, the cost, the material, and everything for you to start your project. Okay, the next part in this module, your concrete start to crack. Okay, the applied moment on this cross section became greater than M crack. That means the tension at the bottom is greater than FR. That means concrete cannot support this tension. That means concrete will start to crack. That means if the concrete cracked, we can throw it in trash. No need for concrete in which is cracked. Concrete in tension which is cracked. No need for it. So keep in your mind, we have neutral axis here. The concrete at the bottom, throw it to trash. Why? Because this part of concrete is under tension, and this tension will cause cracks. And if the concrete is cracked, no need for this concrete anymore. So what do you have at the bottom? We have a steel reinforcement. In this case, your steel reinforcement start to work besides the concrete under compression. Does that make sense? This is how your cross section will behave. So we will have this case. Here is the original cross section. Here is the bending moment. Here is the tension. This moment is greater than M crack. So this tension will cause crack. The part of concrete under tension, which is below the neutral axis, all concrete under the neutral axis will crack. Just a moment. Let's go plug the power. Yes. So all concrete under the neutral axis will crack. We can remove it, through it to trash. So we have only right now, at this moment, under this condition, we have only the concrete under compression still working, and the steel reinforcement at the bottom. Both of them only the two parts that are working with us. Does that make sense? We are going to use this expression to figure out the stress in your concrete or the moment of your concrete. Sigma equal M C divided by. Unfortunately, we cannot use this expression for stress for a cross-section with two materials. Your cross-section must be one material. What do you mean by one material? Right now we have steel, rebars, and we have concrete at the top and steel rebars at the bottom. So they are two materials, concrete and steel. We cannot use this expression since we have two material. What should I do? We have a method called transformed section method. Transformed section method, I can convert one material to another material. So I can convert just for calculations. So not a real transformation. No, we are assuming I will convert the steel reinforcement to equivalent amount of concrete. So this steel converted to equivalent amount of concrete. So by a value called N. If you multiply the value of area steel by N, you can get the value of concrete, which is equivalent to the steel area. So at this moment, we have concrete at the bottom, we have concrete at the top, we can use this expression. That makes sense? This is the reason why it's called transformed section method or transformed area method, because we are going to use a value called N, and this value N called the modular ratio, equal the modulus of elasticity of steel divided by the modulus of elasticity of concrete. Okay. Keep in your mind, modulus of elasticity of steel, Young's modulus, equal 30,000 psi, or equal 30 million psi. 30 million psi. Anybody in this room remember what was the value of E concrete? We covered this last week, I think. 57,000 square root F prime C. So guys, are you still hearing me?
Yes, sir.
Okay. So E concrete, if you go back to the first module, you will find this expression. The Young's modulus of concrete according to ACI. Guys, I'm not saying something from my side. Everything is according to ACI. The Young's modulus of concrete equal 57,000 square root F prime C. And in this case, your A concrete will be PSI, pound per square inch. So the denominator can be derived, can be developed from the value of F prime C. So F prime C is the key to solve any problem. F prime C, I can figure out the value of FR like we did in the previous example. F prime C, I can figure out the E concrete, and E steel is not given. So you have to remember it, 30 million PSI. If you divide this number by this number, you can figure out the value of N, which is called modular ratio. Once you get modular ratio, if you multiply this modular ratio by area steel, I can convert this area steel to equivalent area of concrete. Once you get the equivalent area of concrete, right now we have two parts, both of them are concrete, so I can use this expression. Let's do an example on the transformed section method. Let's do this example, example 4. So guys, we are given this cross section with B equal 12, your depth equal 20, and your total thickness equal 23. And the concrete cracked, and we are going to use transformed section method to figure out the resisting moment. All of this information will be given using transformed section method. So we need some calculations at the beginning. First of all, what is the value of E concrete, Young's modulus of concrete? Equal 57 square root F prime C. F prime C should be given. This value is not F prime C, this value is FC. So F prime C is given 4,000 PSI. This value is only allowable stress. It's something completely different. F prime C is the compressive strength of concrete. This value should be given. By the way, at the beginning of any exam or any quiz, any homework, I'm saying assume any missing data. So if you feel that there is something I have to provide, you can assume it. But for your information, F prime C will be given all the time. We cannot work on concrete without this value. We have to figure out the compressive strength of concrete. So 57,000 square root F prime C 4,000. And you know, area E steel, Young's modulus of steel is already known, 30 million PSI. Both of them should be in the same unit, PSI. So I have 57,000 times square root 4,000. It will be this number, 36,04996.5. 3,604,996.5 PSI. Then the modular ratio is the ratio between E steel and E concrete. I will divide this number by this number. 30 million divided by this number will give you 8.3. This is the first step. Second step. Anybody can tell me what is the value of area steel? How can I figure out the value of area steel? We have how many bars we have?
4.
4. What is the size of each bar?
Number 8.
Thank you. So I will multiply 4, which is the number of bars, time. What is the area of number 8? I need to open a table. Anybody has this table right now? Why? Or I need to figure it out. Do you have the table?
Oh, not at the moment, but I can pull it up.
Okay, just a second.
.79.
Number 8, rebar.
Interesting.
How much?
I see here it says .79.
0.79. Okay, looks good. So the total area of steel will be 4 times 0.79. It will be 3.16. Any questions so far?
No,
Okay.
sir.
So keep in your mind we have neutral axis here, and we have a steel reinforcement. I don't know what is the neutral axis, so I can assume it at distance h. For y, let's do it y. This width is given by the problem 12. This area steel, I figured this out, equal 3.16. But can you tell me what is the distance here between the steel reinforcement and your neutral axis? Any help? I assumed my neutral axis here. At distance y. Anybody can tell me what will be the distance between the steel reinforcement and your neutral axis will be? Any help?
Is it 10 inches?
8 inches.
No, it's not a value because I don't know what is the neutral axis. So how you will give me a value? Neutral
Okay.
axis is unknown for me. So the distance between your steel reinforcement and your neutral axis must be variable. Anybody can tell me what is the expression for this distance? -20 minus what? 20 is the vertical distance between the steel reinforcement and the top. That's right? And
sure?
y is the assumed distance for the neutral axis to the top. If you subtracted the two values, 20 minus y, I can give you the distance, the vertical distance between the steel reinforcement and the neutral axis. Does that make sense? This cross section, oh, where is the concrete at the bottom? In the trash, because they cracked. So this cross section will be converted to equivalent or transformed. Here is the concrete at the compression, still the same. And the steel at the bottom will be converted to equivalent concrete by multiplying N by area steel. So this one is called transformed section. This one is the original section, but we trashed the concrete under tension. Go ahead and put your numbers. This one is 12 inch. This one I assumed it y. This distance I assumed it's not assumed, it's a 20 minus y. Is it 20? Yes, 20 minus y. And this value will be N time area steel. N equal 8.3. And the area steel equal 3.16. So this value will be 26.2. We will work how to figure out where is the neutral axis. It's very easy. It's equation from two sides. The first side, what is the value of this area? 12 times y. This is the area. What is the distance between the centroid of this area and your assumed neutral axis? It's y divided 2. Must equal the area at the bottom. The area at the bottom for this equivalent concrete is 26.2. What is the vertical distance between the centroid of this equivalent area and your neutral axis? It's a 20 minus y. Very easy. Very easy equation. To locate this neutral axis, I will say the top part area time the distance between the centroid of this part and your neutral axis must equal the area of the bottom part time the distance between this part, the centroid of this part, and your neutral axis. You will set up an equation with one unknown, which is y. I can figure it out. So this expression will give you 6y squared equal 26.2 times 20. I got 524.5 negative 26.2y. Just rearrange, you will have equation of second degree equal 0. Solve this equation. A equal 6, B equal 26.2, C equal negative 524.5. How to solve this one? Y equal, if you remember, negative B plus or minus square root B square negative 4AC divided by 2A. Do you remember that? It's math. And I know you are smart in math. So the value of y will be negative 26.2 plus or minus square root b squared 26.2 square minus 4 times a times c divided by 2a. Does that make sense? So I will have two value for y. This equation or this solution will give you two value. Just a moment. So 26.2 square 4 times 6 times 524.5 under square root so negative 26.2 divided by 12. I got 7.4 inch and I have another value. Just a second. Negative 11.2 inch. Unfortunately, the second value is not accepted. We don't have distance with negative value. We don't have distance which is negative. So this solution is rejected. So the value of y will be 7.4. Does that make sense? So the neutral axis will be at a distance from the bottom, from the top, equal 7.2 inch. 7.4. Let me redraw. This is the part of the cross section. This is the neutral axis. This is the equivalent concrete. This distance equal 12. This distance equals 7.4. And this distance will be 20 minus 7.4. It will be 12.6. And this area, equivalent area, what was the value of this area? 26.2. Oh, crashed. Just a moment. So can you see my screen right now?
Yes, sir.
Okay. So this is the area here. Will be, which is in area. You remember how much? 3.16 times 8.3. It's 26.2, yeah. So your sigma stress equal MC divide I. What is the value of I? For this part, your I will be BH cubed divide 12. So 12 times 7.4 cube divide 12. Since your neutral axis is far away from the centroid, I have to add another value, which is the area 12 times 7.4. It's 88.8 times this vertical distance between the centroid and your neutral axis square. This distance will be 3.7 square. So BH cubed divide 12 plus area times distance square plus this part. I will not use BH cubed divide 12. It's very small. So I'm gonna use the area times the vertical distance square 12.6 square. So I can figure out the value of the area. So 12 times 7.4 cube divide 12 plus your area 88.8 times 3.7 square plus 26.2 times 12.6 square. The moment of inertia equal 5,780.4. Your moment of inertia equal BH cubed divide 12 plus area times distance square for the first part. B is 12. H cube 7.4 cube divide 12 plus the area. The area of this part is 12 by 7.4. Time distance, the distance between the centroid of this part and your neutral axis, which is half 7.4. Okay, plus what is the area of the second part? Time distance square. That's enough. I will neglect BH cubed divide 12 because it's a very small number. Your moment of inertia equal 5,780.4. Let's start with concrete. So sigma concrete will equal M concrete time distance C for concrete divided by I for the cross section. Sigma concrete is given. Sigma concrete, which is the allowable stress for concrete, is given 1,350. Equal M concrete, I don't know what is the value of the moment. The distance for concrete is the distance between your neutral axis and the top, because this is the concrete. C concrete, which equal 7.4. Divided by the I, 5,780.4. The only unknown in this expression is your moment regarding concrete. Your moment regarding concrete will be this number. In pound inch. Everything in pound, everything in inch. If you divide it by 12,000, your value will be 87.8 kib foot. But this is only related to concrete. If you are talking about steel. Your value will be sigma for steel equal moment regarding steel time distance for steel, seed steel, divided by I gross or I, and I will multiply this expression by N. Why I multiplied it by N? Because this cross-section is made from one material, concrete. If you would like to transform it again to steel, I need to multiply by N. Anyway, sigma steel is given here. If steel 20,000. Moment regarding steel, I don't know. The distance for steel is the vertical distance between the neutral axis and your steel at the bottom, because this one is originally is steel, so it's a 12.6. The value of I is 5,780.4. What was the value of N modular ratio? 8.3. From this equation, I can figure out the value of moment. Your value will be 1105450.4 pound inch. If you divide it by 12,000, it will be 92.1 kip foot. $92.87.8. So we have moment related to concrete, 87.8 kip foot, and we have moment related to steel, 92.1 kip foot. So guys, this cross section, the allowable stress for concrete 1,350 can support this moment according to concrete. And the allowable stress for steel is given 20,000 PSI. And this allowable stress can give you a moment related to steel 92.1. The final conclusion, this moment that can be applied to this cross section will be how much? Is it 87.8 to satisfy concrete, or it will be 92.1 to satisfy your steel? What will be the final moment? What do you think?
The concrete.
Thank you. It will be 87.8. And this is your final moment of resistance. I will use the minimum value to satisfy or to clarify this one. Hey guys, if you build foundation for a building, I build foundation. This foundation can support only 7 floors. After you poured your concrete and you constructed your foundation, this foundation can support only 7 floors. And you built columns from these foundations. These columns can support 10 floors. Anybody in this room can tell me what will be the final number of floors you can build?
7.
Thank you. Because if you build 10, your column is still good, but your foundation will fail. If you build 7, your foundation is good, and your column will be more safe. Does that make sense? So this is the point here. We have two material, concrete and steel. According to the given information, the allowable stress for concrete and the allowable stress for steel, concrete can support a maximum 87.8. After this number, concrete will fail. According to the allowable stress for steel, 20,000, the steel can support until 92.1. After this number, steel will fail. So what is the final conclusion for this cross section as a whole cross section, including concrete and steel? Both of them will be 87.8, because 87.8 will make concrete almost good and will make steel more good, more safe. But if you apply 92.1, steel will be good, but concrete will fail. I will